because we don't have a ton of time here. Okay, so we all know which well, let's go through all the options first, okay? So what are all of the P over Q, options, Sammy?
Plus minus 1, plus minus 2, plus minus 4, plus minus 8, plus minus 16.
And then you try a bunch of them, and which one works?
2. Positive.
So I have 1, negative 4, 8, negative 16, 16. Take me through it.
2, negative 2, negative 4, 4, 8, negative 8, 16, negative 16, 0. And then that's x cubed minus 2x squared plus 4x minus 8. And then we split that, or whatever.
Okay, so you could keep going with the synthetic if you want, or you could actually factor this. Okay, either way. So if I take out x squared, that's x minus 2. If I take out 4, that's x minus 2. So I have x squared plus 4 and x minus 2. So if I'm finding the zeros, x is equal to 2. What about this one? Plus or minus 2i. And then I have, 2 also, up here. So I could actually write 2 just once. And write, with the multiplicity of 2. So we have all 4 zeros, right? This was originally a quartic. So I have 1, 2, 3, 4. 4 zeros, right? And then in terms of writing it, everyone okay with where that plus or minus 2i came from? Set equal to 0, subtract negative 4, square root it. Okay, so then if I wanted to write, the linear factors, this would be what? X
Minus 2i, x plus 4.
minus 2i. And then x minus 2, x minus 2. Technically, you could write that as x minus 2, squared. But they wanted it, well, that's still a product of linear factors. It's still a linear factor, so that's fine. Okay, good. Let's go over your homework. And then we will continue with our rational functions package that we started yesterday, the Go needs to see.
So helpful.
With Brett. Okay, so numbers 9. The domain was all real numbers except for 0. Vertical asymptote of x equals 0. Horizontal asymptote of y equals 0. Number 10. Domain all real numbers except for x equals 2. Vertical asymptote x equals 2. Horizontal asymptote y equals 0. Number 11. Domain all real numbers except for x equals 5. Vertical asymptote of x equals 5. Horizontal asymptote of y equals negative 1. 12. Domain all real numbers except for x equals negative 3 halves. Vertical asymptote x equals negative 3 halves. Horizontal asymptote y equals negative 7 halves. 13. Domain all real numbers except for x equals plus or minus 1. Vertical asymptote x equals plus or minus 1. 14. Domain all real numbers except for x equals negative 2. Vertical asymptote of x equals negative 2. 15. Domain all real numbers, horizontal asymptote of y equals 3. 16. Domain all real numbers, horizontal asymptote of y equals 3. 17. D. 18. A. 19. C. 20. B. 21. 3. Yeah.
Can you just go to
3 minus 7x to 3 plus 2x. Okay? So it's asking you for the domain and vertical and horizontal asymptotes. Okay, so the domain is, what is allowed in here. Well, there's no issues with the top. The only issue is that the bottom is not allowed to be 0, right? The 2x is not allowed to be 3, so x is not allowed to be 3 halves. So the domain is all real numbers except for that. Good with that so far? Okay. Then the question is, well, what's happening there? Is it a horizontal asymptote? Is it a vertical asymptote, or is it a hole? Okay, well, this does not factor. This does not factor. Nothing cancels. So if there's nothing canceling, then this value that made the denominator 0 is a vertical asymptote. Okay, so there's a vertical asymptote. Vertical goes like this, so it has an equation x equals the 3 over 2, because that factor does not cancel. If it canceled, it would be a hole there. Okay? Then, for horizontal asymptote, you use Bobo, Boden, each DC. So is this Bobo, Boden, or each DC? What's the degree on the x's on the top? The highest.
The same.
Yeah, highest exponent here is 1, highest exponent here is 1, so it's the same. Exponents are the same, divide coefficients. That's what each DC stands for. So that you divide their coefficients. So you divide -7 over 2. So it's y equals -7. Okay. What else? Yeah. 15. Okay, 15. 3x squared plus 1 over x squared plus x plus 9. Okay, so factor that bottom there. Well, it multiplies to 9 and adds to 1. Doesn't, right? Okay, so it doesn't factor. I'm saying you should always check to see if you can factor it. It doesn't factor, right? Okay, well, if it doesn't factor, it's definitely not going to cancel with anything on the top, right? So let's just find where it equals 0. Okay, so I can use, did this have a square root in the answer? Square root of 15. No, okay, good. So I could go ahead and I could do quadratic on it, okay? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, this answers, where that equals 0. Well, I get -1 plus or minus the square root of 1 minus 36, which is -35 over 2. Can I take the square root of a negative in the real number system? No. So there are no real solutions to this problem. In other words, there's no zeros, okay? So if there's no zeros, then there's no place where the denominator equals 0. So there's no issues here, okay? So the domain is all real numbers. Does that make sense? The denominator will never equal 0 based on the quadratic formula. Okay? So then there's no vertical asymptote because there's no place where the denominator equals 0. So the only other question is, are there horizontal asymptotes? Well, is this Bobo, Boden, or each DC? Each DC. So 3 over 1 is 3. So y equals 3 is your horizontal asymptote. Okay. Anything else? No? Okay. So let's finish our notes on this stuff. Okay. So we did the notes on that part. So let's actually practice graphing now, which is what you're going to do in your homework over the weekend. Okay? So first we have to identify, any horizontal asymptotes, vertical asymptotes, points of discontinuity. We have to draw in those asymptotes and then make a table of values, including those x values in the table, and then plot the points. Okay? So let's take a look at this one first. Factor the bottom. Okay? What multiplies to -3 and x to 2? 3 and -1. Since the leading coefficient starts with 1, I can just do my shortcut and write x plus 3, x minus 1. Okay? So I have x minus 1 over x plus 3, x minus 1. So I rewrote it. Okay, so first of all, are there any horizontal asymptotes?
Yes,
Why?
because the volume is bigger.
Bottom degree is bigger. So what's the horizontal
Y
asymptote?
equals 0.
Y equals 0. Okay, degree on the bottom is bigger than the top, so y equals 0. What about vertical asymptotes?
Yeah.
Where?
-2.
Why?
Is that right?
Yeah. Why?
Because x minus 1 and x minus 1 cancel each other.
So that means what's happening at x equals 1? A hole. Okay? And the one that didn't cancel is the vertical asymptote. Okay?
I'll go like
Right?
Right.
Okay. So then we go ahead and we start by plotting where our vertical asymptote is. Okay? So our vertical asymptote is at -3. And our horizontal asymptote is y equals 0. So you can just go ahead and plot plotted by you can go ahead and make the dashed lines, right? And then when we create our table, we want to make sure to put values in our table around those points, okay? So I'm going to put like -3 here. So I'll include, you know, -2, -1, sorry, other way. -4, -5, -2, -1, 0, 1, 2, 3.
Wait, what are you trying to, what did you say?
I'm putting these special points in my table. Watch it. And I want to have points, you know, around it. Okay. Okay, so now I look at what the values are going to be around those points. So let's plug them in. Okay? And I can plug it in if I want to this simplified version right over here. Okay? So if I plug in -5, it's 1 over -5 plus 3, or 1 over -2, which is -1/2. Plug in -4. What does that give you? -1. Plug in -3. What does that give you? Undefined. I'm going to put E for error. Okay, plug in -2. 1. Plug in -1. 1/2 or 0.5. Plug in 0. 1/3. Plug in 1. Okay, so I'm actually going to put here, if I plug 1 into the simplified one, what would I get out? Okay, so it works in the simplified one, but we know that originally over here, there was an issue with 1. So what's happening at that point? That's where the hole is. Okay, I still need to know the y value though, because I need to know where to put that hole. Right? Okay, because originally, you know, 1 was an issue, so I can't ignore that fact. Okay, so plug in 2, you get 1/5, plug in 3, 1/6. Okay, so let's plot them. So go to -5, 1, 2, 3, 4, 5, -1/2, -4, -1. Okay, so clearly this branch is doing that because it needs to be approaching those asymptotes. You can't break out of those asymptotes. Okay, so it has to be doing that. All right, then I'm my asymptote at -3, so I skip over it. Then at -2, I'm up here at 1. At -1, I'm here at 0.5. At 0, I'm even lower. At 1, I'm even lower with the hole. At 2, I'm even lower, even lower, even lower, even lower. So it's doing, you know, hole, something like that. Maybe I do my hole in a different color. Yeah. And that's the graph. Questions though? Okay. So let's look at another one. Okay, see if you guys can first fill in the blanks. Yeah. All right, no, give everybody a second. Okay, so Sammy, are there any horizontal asymptotes? Y equals 0. Good. Amanda, what do you think about vertical asymptotes? Good. And Rafael, what do you think about points of discontinuity or holes? Very simple. Yeah. Good. So the only point special that we have to make sure to include in our table is -1. Okay, so let's go ahead and draw those asymptotes. And then we can put some, you know, points around it. So here, you know, I'm going to get an error. Okay, -2, -3. Okay. So if I plug in -2, what do I get?
-1?
If I plug negative 2 in. Or we can start all the way at compare at negative 5 and make our way across. That's fine. Plug in negative 5. Negative 3/4. So negative 0.75, right? Plug in negative 4. Plug in negative 3. Negative 3 halves. Negative 1.5. Plug in negative 2. Negative 3, right? Plug in 0. 1. 3/4, right? Plug in 4. Or plug in 2. Plug in 3. Oh, sorry, this is not 3/4. This was 1.5, sorry. Sorry, there we go. Okay, so I'm at negative 5, negative 0.75, then negative 1, negative 1.5. Okay, so this one is doing that. And then on the other side, 0, 3, and 2, 1. And that. Good? Okay. So, let's try another one. What do we have to do first on this next one? Factor it, okay? So you guys factor it there. Okay. Leonore, how does it factor?
X is 4, x minus 8. And then x plus 1, x minus 2.
Any horizontal asymptotes?
Yeah. 1.
And what do you think, Jackie, about vertical asymptotes?
X equals negative 1.
And the whole?
2.
Good. Any questions? Because that would cancel, so it would be a whole then. Yeah.
Where did you get the horizontal asymptote?
Bobo eats DC on the original problem. So it's eats DC, right? 1/1. Any other questions so far? Okay, so now let's draw those asymptotes. So x equals 2. Sorry, x equals negative 1. Just looking at the other one. Equals negative 1, thank you. And y equals 1. And then I have to include in my table negative 1 and 2. So, this is going to have an error, and this is going to have an error.
I hope the 2 have an error.
Yeah, I'll actually write the points at 2, but yeah, it's technically an error, but I'm just filling in, in parentheses, kind of where would it be, so I can make the whole. Okay. How do you guys fill them in? Oops. Don't there? Somebody want to read me the values again?
7 over 2. 6. Negative 4.
Like 0?
Oh, yeah, negative 4 at 0. Negative 3 over 2 at 1. Negative 2 over 3, which is the whole at 2. Negative 1 over 4 at 3. 0 at 4. And 1/6 at 5.
Okay. So I'm at 1, 2, 3, 7 over 2, which is 3.5. So, you know, this one's going to do something like that. And then 0, I'm at 4, 2, 3, 4. So it's going to do something like that. And at 2, I'm at negative 2/3. So, you know, there's the whole. Good? So here's a little matching. Take a few moments to see if you can just, for the summary, match each of these with the appropriate equation. Well, you can try it on your own. Go over it next time if you want.